Okay, this is a test. I think this should be like that. What do you think? Is it good? Whoa. Hey guys, welcome back to the lab. It's actually been a pretty exciting week in spaceflight. We had Starship integrated flight test number 5. That was pretty exciting. That booster catch coming in, chopsticks catch, I like that. Also, the ship was able to re-enter, and they're gonna obviously have to do some updates with the heat shield and some reusability aspects of the Starship system, but looks really cool. We had Europa Clipper launch on a SpaceX Falcon Heavy. They expended all 3 of those boosters, so say goodbye to those. That was, I think, the lifetime leader of the boosters, like with 20 or 21 reuses. So, and then also on top of that, there was a Falcon 9 launch that launched the Hera mission for ESA. So within 1 week, 3 different SpaceX rockets that launched, doing cool different things. I actually want to do some talking about the Euclid telescope. Wait, that's weird. Capture. Why? So today I want to talk about some of the cool images that just came out of the Euclid telescope. Euclid is a ESA mission, the European Space Agency. There's a really awesome telescope that they've launched, I think it was last year on a Falcon 9, and I'm just copying some images right now so that I can show them to you guys. Just the resolution, some of the stuff that's coming out of here, just amazing. So let me first pull up this image right here. Okay, so this is from like this actually just came out yesterday. This is like page 1 of the Euclid Atlas. This is actually just 1% of the sky that they're going to be actually surveying over the course of this mission. The Euclid mission is supposed to basically scan a large portion of the sky, kind of missing, right, as you can see, the Milky Way in general, because there's just kind of a lot of stuff in the way there, and we're really trying to look very deep into the universe to try to better understand large scale structure, and have different galaxies interact with each other. We're going to look at a few like really cool spiral galaxies and maybe some lensed objects. So like the resolution is just insane. I can't show you on this image exactly because you reach a resolution limit, just because ESA hasn't given out the full high resolution image. A really cool video that you should check on YouTube that just got released by ESA, showing the power of 600 times magnification in this image alone. You're going to be able to image all these parts of the sky, which is a large portion of the sky, but also with incredible depth and resolution. So we'll be able to see quite a bit. Here's an example of one of the images that has been kind of hand-picked, cherry-picked from that wider initial swath that they recorded. And I mean, like, look at the depth, resolution. It's so incredible. Each one of these things is a galaxy. I wanted to, take that whole initial data release, and I wanted to just kind of scroll through it and see just what amazing things I could find. But like I said, ESA didn't release the entire catalog with its full resolution, 208 gigapixels, I think it was. Right, that's not downloadable yet, so I'll have to do that later. But yeah, I just wanted to give you an amuse-bouche, a little taste for what sort of things are possible with ESA's Euclid telescope. Okay, so that's the Euclid telescope. But trust me, there's more. Let's take a look at JWST. So this is the James Webb Space Telescope. He's my favorite. The reason I'm bringing both of these up is because, one, they're just incredible high-resolution space telescopes that are really, informing the next generation of astronomers. Euclid is focused on understanding big cosmological questions like the nature of dark energy and dark matter, distribution, and understanding how large-scale structure is formed and interacts and changes over the evolution of the universe. And the James Webb Space Telescope is doing something similar. It's able to resolve really far, deep images of distant galaxies, and increasing the resolution is something that was a huge step up with JWST, but also, of course, it's able to see more in the infrared, so it's seeing things that are more redshifted, which means it's able to see galaxies and objects that are much further and older away. Another thing that I think is kind of cool is these two telescopes, they're both actually stationed at the same place. There's something called a Lagrange point. There's 5 Lagrange points around Earth. There's also 5 Lagrange points around Jupiter, for example. A Lagrange point is like a stable equilibrium, if you will, somewhere where there's kind of a gravitational area that's actually pretty stable to park at. So JWST and Euclid are actually, they're both at the Earth L2 Lagrange point. This is an example of some of the L2 orbits. I think this is kind of cool. There's Earth. This is showing the trajectory of the Euclid telescope. And this little spot right there is actually the L2 point itself. And so Euclid actually is constantly orbiting around it, and same with JWST. So they're kind of, astronomical buddies, space telescope buddies. But they're both kind of unlocking different secrets of the universe with incredible resolution. So let's get into some of those JWST images as well. I just picked just a couple of random ones because I thought it was pretty cool. Didn't really matter exactly too much. What are we looking at, right? So this kind of blue area here, the cyan area, is actually ionized hydrogen. So this is like a pretty young part of the galaxy. I believe this is in the Milky Way galaxy that we're looking at. And this is like a little bit of a star forming area. Let's see if I can zoom in. Yeah, again, resolution issue with downloading stuff from online. But yeah, all these bright objects here that aren't fully resolved, those are actually like, stars in the foreground, right? My hand is here, you can see me, but my hand kind of obscures that image of my face. So that's kind of what we're seeing there. This is, explosive star forming activity, so much going on. And yeah, so just incredible. I mean, look how populated this image is with all these different stars. Let's check out a different image. How about this one here? Yeah, wow, okay, this is another cool one. So JWST has just incredible resolution. So these are gravitationally lensed objects, which means there's something very, very massive in the middle. Something, around here is causing all these things that are behind it. Again, imagine my hand is this really massive thing. Light from my face is going to you, but it's also going down this way. And if my hand is massive enough, it can actually bend it back up towards the camera for you to see. And that's happening all around here. So there's something super massive in the center, which is lensing some of these images. And I mean, just even without the lensing artifacts, this is still a super cool image. So this is another cool one. So this is not an image from JWST, this is just a spectrum. So, over a wavelength of light, we have different intensities. This is talking about amount of light being blocked. Anyways, so you see these white data points are the actual observed data. The purple is like the best fit model that, what the computer and what the scientists have deduced is what best represents what's being observed. And so there's this little artifact right here where there's a kind of a bump in the amount of light being blocked. And that is being associated with quartz or silicon dioxide crystals in the atmosphere. So the JWST team thinks that in this planet, WASP-17b, this is some exoplanet that's orbiting another star, actually has clouds of quartz, like sand, if you will. So that's pretty crazy. And this is an artist's rendition of these quartz clouds. This is all available on the Space Telescope Science Institute or the Webb Telescope website. But I think that's pretty cool. Quartz clouds in an exoplanet. You want to go there? Wear a mask, that's for sure. Let's check out one more thing here. So this is pretty cool. So this is another one of these lens artifacts. Super massive object in the center right here, right? And there's something behind it that's emitting light in all directions, okay? And some of the light goes up like that, some of the light goes like that, some of the light goes right to you, and some of the light would have missed you, except this really massive object is actually curving the light back to the camera. And so we get these really cool lensed artifacts, right? And so this on the right side of the image is a zoomed in version of what's here. And they actually highlighted some things that I wanted to highlight for you. So here, this section is more or less a galaxy, right? I mean, you can kind of see it's like a flat disk, and there's one little bright spot there. I'll get to in just a second. But then there's also this whole lensed artifact. That's the same thing. We're looking at the same galaxy, but light that this is more head-on, and then some of this is actually, has been lensed from coming out in other directions. So that in and itself is amazing. Thank you, Einstein and general relativity, and all the people who have determined that really massive things bends light in the universe. I think that's awesome. But what's this little dot we're looking at? Well, let's go back here. So this is the galaxy. There's one dot. That's actually a supernova going off. Okay, so one of the stars amongst the hundreds of trillions, maybe, hundreds of billions, has gone off, has erupted, and we're actually seeing it come up again in the lensed image. And so it's visible here, it's visible here, and if you actually read the description of this image from the JWST team, there's a note that says a third artifact should be visible in the year 2035 because that light has already been emitted a long time ago, astronomically speaking, but that light is still traveling because it took a longer path around this bending central object. And so, in about 10 years, we can do another observation. We should see another supernova show up. Okay, and here's the last thing I wanted to show. Okay, so the recording kind of just got cut off at the end there, but basically I was showing 19 different spiral galaxies from some of the JWST images during the first couple of years of observation. And the point is that the universe is vast. I'm showing you each one of these galaxies because they conceivably could have been our home. And so there's objects out there in the universe that are similar to where we live now, and it's perfectly reasonable to think that something just as exciting as here could be happening there. So I encourage you to maintain your curiosity, and let's embark on a journey together to learn more about the universe and to keep investing in science and the pursuit of knowledge for humanity. Thanks for coming along with me today, and I hope you have a good one.